Hey there guys, Erica here from Highway 49 RC. As you guys know, the Highway 49 RC shop has gotten a CNC mill. Man, this is so exciting. And of course, you can't really use a mill very well without tooling. Clamping stuff, tooling, things like end mills. You need measuring things, so you need like dial indicators and that sort of stuff. So my dad and I picked some of that stuff up recently and it came, and that's what I've got here to show you. So I figured I'd do a bit of a tooling haul, as you guys have seen in the video title. You know, just kind of show what I've got. Super basic stuff, nothing fancy, because I mean, tooling for machine tools is actually very expensive. So you can't really just go and buy everything you want, because you will then go bankrupt and not be able to pay your mortgage. So that's a problem. But we got enough for ourselves to start messing around, drilling some holes, milling some slots, and figured I'd show you that today. The first and most important thing when it comes to milling and machine work is work holding. Having a good way to hold a piece of material that you're drilling a hole in or milling a slot in or face milling is extremely important. And the thing that I've heard people say is that when you buy a vise, spend as much as you physically can on it, because it is the only tool that you will be using every single day. And I would say I agree with that. So we got a Kurt vise here. Got a nice handle that removes. It feels really nice, and it's heavier than my anvil that I use for blacksmithing. So I mean, that's something to say about it. I'm really excited about using this. I think it's going to be great. And with a vise, you also tend to want a set of parallels. So what parallels are they're basically pieces of steel. I think they're hardened, and they come in pairs, and what you do is you stick them in the jaws of the vise so you can set your work down on those parallels. So say I was working on this 1, 2, 3 block, I'd set it on there, turn it, it sits on the parallels, and I think those are within 1,000th, or like 1,000th tolerance, and clamp it, and there you go. That's basically what parallels do. They make sure that your work is parallel to this face of the vise, which should in theory be parallel to your table. When talking about clamping, in addition to a vise, it is also super important to have a clamping kit. This will allow you to have, or to be able to clamp very large pieces that won't fit in your vise, strangely shaped pieces. So if you've got a weird bubbly curved sort of thing going on, you can clamp it with a clamping kit. The way these work is you have T-nuts. These guys, they're shaped like a T. And then you've got these threaded rods. Thread one in. They go into the T-slots of the table. So, I'll show you on this one. It basically slides in perpendicular, and it allows you to clamp to the table itself. They also generally come with these guys, which are like step blocks. And so you take one of your step blocks and one of these guys, which has an angle on it. This goes on the top. Say we want to clamp onto this. No, let's say we want to clamp on this. You can set it like this. That will wedge onto there. You want it mostly parallel with the table. And then obviously this is too long, but then you take a nut and you thread it on. The pressure downward on this piece is being transferred to the table here on this triangle and to your part. We also picked up some 1, 2, 3 blocks. Those are just a general, like, everyone should have them kind of thing when it comes to milling and machining. They're nice because they can be used as a reference surface, because these are also, I think, within 1/10,000th. The parallels, I just realized, I think I said 1,000th, I meant 1/10,000th. So they're pretty close. And so that means you can use them as a reference surface. So if you put this on top of, say, this, you can say, okay, the surface of your part is exactly 1 inch away from your part, or 2 inches, or 3 inches, and that can be useful when setting the height of your cutter or your drill bit off the surface of your material. But they can also be used as clamping blocks, or so you can take one of these triangle clamping blocks like I showed before, set it upright like that, and boom, there you go. It's an inch higher off the surface, or an inch higher off the table. Also, I forgot to mention, this is a right angle block that we've had for a while. I'm not sure where we got it, but It's another one of those clamping things. It can also be used as a right angle reference surface. You can bolt it to your table, bolts apart to here, that sort of thing. And of course, what good is clamping to your table and trying to drill a hole when your drill bit is not perpendicular to the table? It's not any good, is it? Unless you're trying to drill an off-center or an off-angle hole. So we also picked up a needle indicator. I don't know if that's what these are called, but it's basically one of these little guys. I don't think this is open. I'm not going to take it out of its packaging, but it has a little needle up here. You move that and it moves the dial basically, and this is used, this gets mounted in the quill, which is right here. It's just above there, you can't see. It gets mounted into the quill and basically moved along the table, and it's used for tramming in the head of the mill to the table or to the vise, or making sure that your part is level. If it's a part that is, if you're not able to use parallels on it, you can use this to get it, parallel to the table essentially. And then along with it, we got this like holder for it. I don't know how it works or how to use it, but anyway, we got one because the guy that we got the mill from, he didn't say anything about the head being trammed in or not, but I'm gonna guess that it's probably not great. So we'll have to do that at some point too. Not for now, we're not doing anything super serious, so no big deal. So now that we've got the table flat and our material clamped, and we want to drill a hole, how do we know where to drill the hole in reference to everything else? Because, I mean, you can drill something, 1/1000th of an inch this way or 1/1000th of an inch this way. I mean, you can get pretty precise, but what good is being precise if you don't know where you're supposed to be drilling the hole? That's where this guy comes in. This is a mechanical edge finder. So the way it works is there's like a little spring inside there, you can see, and this gets chucked into the spindle, and you run it up against your material, and as it spins, eventually, once you get it perfect to the edge, it will find its center. I can't do it because it's kind of stiff and I can't do it with my fingers, but it basically runs in, finds its center, and once it stops wobbling, that's when you know that you found the edge of your part. So then basically this is 1/2 inch. So I'd subtract 1/4 inch from whatever my DRO says, and then that number on the DRO would be exactly on the very edge of my part. So because it's 1/2 inch, I'd subtract 1/4 inch, and that puts the center of the quill directly over the edge of my part. Then I know, okay, I need a hole, 3 1/8 inches this way, zoop, away I, and then drill it, and away I go. And last but not least, we got some end mills, some ER32 collets, and ER32 collet chuck. So for end mills, these are like aluminum titanium nitride coated. I think that's what the gold coating is. I don't recall. But this set came with 2 and 4 flute end mills. So the 2 flute end mills are, they remove material faster. They're better for cutting slots or plunging because there's more clearance for chips because there's only 2 flutes. But they produce a rougher finish. That's where the 4 flute end mill comes in. The 4 flute end mill is more for doing finishing passes and cleaning up stuff, getting a nice clean finish. But it's not so much designed for plunging because there's not as much chip clearance. This is a set of 3/16 all the way up to 3/4, both 2 and 4 flute end mills, which is great. But you gotta like hold the end mill somehow, and that is where collets come in. So on a mill that is, so this mill is set up for Cat 40 tooling. It's a 40 taper, which is what this taper is. This is called a 40 taper. Don't know why. You can look it up. It was developed by Caterpillar. But the way this works is, so like a Bridgeport has R8 tooling. So that is set up in such a way that the collet itself has a thread for the drawbar on it already. So you can put your tool in, and then just stick this up into the quill, and away you go. But this is a little bit different. So mainly because Cat CAT 40 tooling and BT 40 tooling is designed for CNC machines, so it's designed to be able to sit in a tool changer. So it'll sit in a U-shaped slot, and then you'll have a some sort of arm, swing around, grab it, stick it up into the quill, and then take the old one and slot it back in there. And basically it makes it so you can have a tool mounted, but have only like one thing that the tool changer has to move around. Instead of having to hold the tool and the collet at once, this makes it easier. But the way this works, it's pretty simple, it's nifty, and I like it because it's big and beefy. I like that sort of stuff. So you take collet, stick it inside the tapered end, grab your end mill, slip that in there, take the nut over top, that threads on, tightens down. We need to get a spanner wrench because this has got notches on it, but we don't have a spanner to tighten it. And there you go. Now your end mill is mounted. Better not drop this because it will break. But then you just loosen it and out pops your end mill. And then if you're using another 1/2 inch end mill, say I want, alright, go for a 4 flute now, put the 4 flute in, tighten it down, away I go. But we got a set of, what's this, 3 times 1, 2, 3, 4, 5, 6, 7, 21 collets, all the way from 1/8 all the way up to 3/4, which is good. It's a good span. Yeah, I think that pretty much covers everything that we got. And there you go. That's all the tooling that my dad and I got for the mill. I'm looking forward to putting it to good use because it was pricey. It was definitely a little pricey, so I'm glad that it'll be able to get put to good use. So yeah, with that, be sure to stay tuned for the first chips video where I'll show like what got put back together, you know, show how we wired the machine, and show turning it on and actually making some chips, which is exciting. I'm super pumped. I'm super pumped for that because it's going to be awesome. So stay tuned for that. Hope you guys have enjoyed. Please leave a like, subscribe, comment down below. Also follow me on Instagram at Howie49_RC. And yeah, I guess that's it. So see you in the next one.